Okay, welcome to What Do You Want to Know Wednesday. Today I'm going to be talking a little bit about the addition of the new 12-hour time point into AMTS version 4.15. This is a new addition to our program to help users calculate the rate of degradation, or KD, of NDF in forages. So traditionally in the program, we've been able to use a single time point NDFd, 24, 30, or 48 hours are the most common ones. And this has been around for quite a while, allowing us to estimate KD from a single NDFd time point and lignin times 2.4. A few years ago, of course, we added the 3 time point NDFd, which is done at 30, 120, and 240 hours for forages. However, now we have added an additional time point here. This is an optional time point. We'll get into that here in a second. And that is the 12-hour time point. So now a user can use 12, 30, 120, and 240-hour NDFd to estimate that rate of degradation for fiber. Some labs are offering this 12-hour number and have been offering it for a little while. So we are now allowing that to come into the calculation so that users can have a little bit more accuracy when determining that KD. And the next couple slides, I'll step through what that means for you when you're using the program. So this is using some data from Dairyland Labs that have generously offered up some of this data. So we now have this ability to use a 12-hour NDFd time point as an optional input. The question, of course, is how and why do we have this, and how will it change my numbers when I'm predicting ME and MP allowable milk? So the 12-hour is probably important to characterize some of the forages we have typically on dairy farms. Here is some summary from Dairyland Data, basically taking alfalfa with low NDF, alfalfa with higher NDF, corn silage, and then grass forage. So you can see these 4 different types of forages. Essentially, if you look at, let's take corn silage as this big center one. This is giving us an idea of the amount of the digestible NDF that's digested before 30 hours. And so you can see with corn silage, it's a fairly narrow peak, and quite a few of the samples quite a bit of the samples are digested kind of all in this fairly narrow range compared to the other forages. So what this would mean is that we probably would suspect that a feed like corn silage, the 12-hour NDFd will be a little bit less important than a feed like low NDF alfalfa. Okay, and so what you can see here is alfalfa, a lot of it's gone before 30 hours, but there is a very wide range. And so this would indicate to us that it might be worth characterizing that 12-hour time point to try to get an idea of digestibility in that first, basically in that first 30 hours of digestion. So it's probably important to characterize in something like alfalfa, probably also in high quality grass. That's this brown zone here. You can see that there's quite a large range on that high quality grass as well. And it's probably not really as important in something like corn silage. And just to reiterate, this 12-hour number is an optional input. So if your forage lab doesn't offer the 12-hour in the package that you are currently getting, or if they just don't have the 12-hour available for NIR yet, whatever it might be, don't worry, you can still use the 3 time points, and you should have a fairly good accuracy. This is just going to help increase that accuracy of determination in the KD. So when we're talking about the 12-hour NDFd for alfalfa, this is using some of that Dairyland data, basically looking at 3 different levels of NDF. So that's how they kind of parsed apart this data set. And what it shows is that when you get to the later time points like 30 or 120, the differences between feeds of different levels of NDF kind of starts to narrow up. But here in this earlier stage, you can see that some of these especially low NDF alfalfa samples, they tend to be a little bit different than the high NDF alfalfa samples. And when we're doing our calibrations for NDFd, this is something that probably will become important to think about, because that 12-hour number probably gives us a little bit of a better understanding of the variation in a given forage. So when we actually put this down to real data and understanding what's the effect in the model, generally we probably are going to see, if you're using the 12-hour versus just the 3 time point, 30, 120, and 240. If you're including that 12-hour, we're probably going to see an increase in the calculated KD, and about right around the average for a subset of the data that I've analyzed is right around 2.3 percentage points, meaning if we had a 3 time point NDFd of 7% per hour, a 3 time point KD of 7% per hour, we would see that probably go a little bit closer to 9.6 per hour. This will likely mean, basically, probably means about less than half a pound change in ME or MP allowable milk in most diets. Probably a little bit more change in diets with higher inclusion levels of alfalfa, and a little bit less change in those diets that have a low inclusion of alfalfa. So just kind of something to think about there, that we're talking about less than half a pound change in ME and MP allowable milk with that addition of the 12-hour time point. But the good thing is this should help decrease error in KD determination, meaning the accuracy of our model we expect to be a little bit better in alfalfa-based diets with that 12-hour time point. So that's a benefit there. All right, in corn silage, it's probably not going to mean much. There's not really a lot of variability compared to the other time points. Just visually looking at this graph between something, let's say, of a BMR, and they're calling an unknown variety here, but essentially we're kind of looking at BMR versus conventional. So essentially this is saying that the 12-hour is not really telling us that much more about the digestibility of this forage. So rates still may increase a small amount because there's still a numerical change here. We're looking at around 0.16 percentage points, so 5.5 versus 5.66% per hour on a typical KD. So this is a pretty minimal change in the end. It means in most diets probably less than a quarter pound ME allowable milk or MP allowable milk. So relatively small change. So these numbers between corn silage and alfalfa could be additive in some cases. So essentially, we're really looking at still less than a pound of change in ME or MP allowable milk with the inclusion of 12-hour NDFd for your major forages. I don't have a slide here for grass silage, but especially if you're looking at high quality grass silages, especially maybe European type grass silages, they are probably going to look a little bit more like alfalfa in terms of the value of that 12-hour time point versus corn silage. But overall, any inclusion of this 12-hour will help decrease the error in KD determination because we're using more information in our model. So to kind of just wrap it up, basically, the NDFd calculation, this is the official CNCPS method of rate calculation, meaning we're using the official CNCPS rate calculator. So it's a single digestible pool of NDF. Cornell has not incorporated the two digestible pool model into the CNCPS at this point. So I know there's a lot of talk about the fast and slow pool of NDF. However, that's not been officially included in the CNCPS. So we are sticking with the official method currently, which is a single digestible pool. So that, again, that fast and slow are not used in the version 655 at this point. 12, 30, 120, and 240-hour time points are used to calculate a KD. That's basically all of those time points can be used for a forage KD. The 12-hour time point is optional. So you can either use 30, 120, 240, or 12, 30, 120, 240 if you're using multiple time points. The use of the same time points in a non-CNCPS rate model, NDF rate model, will not calculate the same KD for a forage. So if you have, if you're using another model that is using a non-CNCPS method to calculate the NDF KD, you're not going to get the same KD result, obviously, and therefore you wouldn't have the same inputs for the program. And therefore the prediction of ME and MP allowable milk will not be similar between models. Because we're using the official CNCPS method, we would say that the AMTS calculation is still consistent with the CNCPS method for calculation of ME and MP allowable milk. That is our goal, and we will always stick with that official CNCPS method. So that kind of wraps it up for the slideshow. I'm just going to show you very quickly how to do this in the program. So we are here in the program looking at a corn silage with the calculator open. And so what we can see is we have this option of 12-hour now. We used to only have 30, 120, and 240. And now you can see we have the ability to enter in a 12-hour. Now, when I say it's optional, what I mean is if you don't have a 12-hour number, you can just put 0, and it'll only calculate with those other 3 time points. Okay, if you do have it, you can enter in a value, and it will calculate with all 4 time points. It's as simple as that. The XML import is designed to do the same thing. So basically, if it sees a 12-hour NDFd, then it will use it. If it doesn't, then it will not use it. So it should be very seamless and very simple for your day-to-day use of the program. And that about wraps it up. And of course, if you ever have any questions, please feel free to contact the team at AMTS. We are always happy to help. Thanks. Bye.